pangolin tool for resilient patterns.
Welcome to a new episode of Non-Conventional Design. Today, we're diving into the fascinating journey of pattern design, from the sacred symmetry of Islamic art to the modern Escher pattern, and uncovering how breakthroughs in mathematics didn't just change equations, they transformed aesthetics itself. Patterns are more than decoration. They're a language, a way civilizations expressed beauty, mathematics, and even spirituality. Pattern design is a masterpiece of geometry. But what if we could push it even further, into a new dimension of analytical precision? Through mapping and gradient mathematics, designers like Escher have transformed the way we think about patterns, taking them from hand-drawn star grids into dynamic, mathematical forms. Today, we'll explore how Islamic patterns can be pushed into analytic forms, the step Escher has taken in his design process, how this could enhance traditional star patterns, and why this leap wasn't possible centuries ago. Traditional Islamic patterns are built with compass and straightedge construction. Circles, diagonals, and repeated polygons form grids that generate stars and interlocking tiles. This method is elegant, but it's constructive geometry, not analytical geometry. The rules are based on proportions and alignments, not equations. That's why the patterns feel alive, human, and symbolic, but they're also bound by the limitations of hand construction. Now imagine applying mapping functions, where each point in the plane can be shifted according to an equation. Suddenly, a simple star pattern can stretch, warp, and flow like a fluid, while still keeping its geometric essence. Add in gradient mathematics, measuring how values change across space, and patterns can be guided by invisible mathematical forces. Instead of repeating static tiles, his system uses mathematical mappings and gradients to generate continuous transformations of form. Think of it this way. Traditional Islamic stars are fixed. Escher's analytical patterns are fluid. The move is from a pattern you construct with tools to a pattern you calculate with equations. Applied back to Islamic design, this approach could expand the vocabulary of patterns. Stars could shift across a surface, adapting scale and orientation. Symmetry could remain intact while complexity increases. Entire facades or textiles could breathe with mathematically guided variation. It doesn't replace the tradition, it extends it into a new mathematical era. So why didn't Islamic artisans explore this centuries ago? The answer lies in mathematics itself. In the Golden Age, geometry was constructive, rooted in Euclidean tools. Analytic geometry, gradients, and mapping functions only emerged later, with thinkers like Descartes and Newton in the 17th century. Without the concept of coordinates, equations, and functions, the idea of warping geometry mathematically simply didn't exist. The artisans mastered beauty with what they had, but the leap into analytical forms needed a new language. Algebra plus geometry. So today, by combining Islamic tradition with modern mathematics, we can create designs that honor the past but push into the future. From stars to mappings to gradients, the journey of pattern design continues. And maybe the beauty of Islamic geometry wasn't just in what it created back then, but in how it inspires us to go further today.